let's talk about mutually exclusive events, which also go along with our addition rules for probability. Two events are said to be mutually exclusive if they cannot occur at the same time. That means they have no outcomes in common. Another word for mutually exclusive is disjoint. So these words are interchangeable. They mean the same thing. Mutually exclusive, disjoint. Here we have two Venn diagrams. The first one, notice there's some overlap here with A and B. So A and B are not mutually exclusive. They have something in common, at least one outcome in common. So they are not mutually exclusive. In the second diagram, notice there is no overlap. So A and B would be considered mutually exclusive. Take a moment and see if you can apply this definition of mutually exclusive or disjoint to these four situations. Pause the video, try them on your own, and then resume to see the answers. Make sure you hit that pause so that you can try this on your own. Remember, the idea is to learn, and a great way of learning is learning from your mistakes and correcting them. So give yourself that opportunity to make mistakes and then learn from them. Okay, you got your answers? Here we go. There are 10 solid colored marbles in a bag. The two events are draw one red marble or draw one blue marble. Are they mutually exclusive? Yes. We have solid colored marbles, red or blue. I cannot draw one marble and get both red and blue. So they are mutually exclusive. You're walking down the street when you meet a man with an umbrella or you meet a man with a raincoat. Are these events mutually exclusive? No. The man could have both an umbrella or a raincoat, especially if it's raining. You are looking for a job. You get a full-time day job as a teller with a bank, or you get a full-time day job as a cashier at a store. So full-time day job, we're usually talking 8 a.m. to 5 p.m. Can we do both of those things? We cannot be two places at once, so these are mutually exclusive. So we cannot do both at the same time. While outside, you get stung by a bee or stung by a wasp. You could be incredibly lucky and get stung by both, so these are likely not mutually exclusive. Just a fun little way of incorporating this idea of mutually exclusive. Can they happen at the same time? If yes, then they're not mutually exclusive. If no, then they are mutually exclusive. I know that can be a little bit confusing. Just know that mutually exclusive, mutually exclusive events means we're excluding. They have nothing in common. Okay, for the next warm-up, I want you to see if you can determine the probabilities of the following events and see if there's a way that you can come up with a rule for events that are mutually exclusive and possibly a rule for events that are not mutually exclusive. So first decide if the events are mutually exclusive, and then find the probabilities for rolling a single die. Just like before, pause the video, try it on your own, come back and check your work. Correct your mistakes. Don't just erase them, but write down why you got them wrong so that when you go back and look at it, you'll understand what your reasoning was and how you corrected it. All right, are we ready? Rolling an odd number or rolling an even number. These are mutually exclusive. We don't have odd numbers that are also even numbers. So the probability of rolling an odd number would be rolling a 1, a 3, or a 5. Probability of rolling an even number, 2, 4, or 6. Out of 6 total, the probability of rolling an odd number or an even number is certain. It's 1. If I roll the die, I'm absolutely going to get either an odd number or an even number. How about in F, rolling an odd number or rolling a 1? Are these mutually exclusive? No, 1 is odd. So when we talk about rolling an odd number or rolling a 1, 1 is already in that first event. These two events are not mutually exclusive. What would be the probability? Well, since 1's already included in the event, I don't have to count it again. I have 3 unique simple events out of 6 total. So my probability is 1/2. Rolling an even number or rolling a number greater than 3? Well, an even number, 2, 4, 6, or a number greater than 3, 4, 5, and 6. How many different unique events do I have here? 2, 4, 6, and 5. I've already got 4 and 6 in the first event, so I don't want to count it again. 2/3. These are not mutually exclusive. And the last one, rolling a number less than 2 or rolling a number greater than 2. A number less than 2, we only have 1. A number greater than 2, 3, 4, 5, or 6. So my probability is 5 out of 6. These are mutually exclusive. I have nothing that overlaps in those two sets. And I'm going to highlight all of these so that we can see how they're being counted. That I don't double count the 1, the 4, the 4, or the 6 in F and G. So you can come up with your own words how you would find a probability like the ones above. We can do it intuitively, like we just did, using our brains, thinking about the structures, and we don't want to double count simple events. So if a simple event shows up in 2 different compound events, and we're looking for the probability of those compound events, then we don't want to count that simple event twice. We don't like double counting. Double counting can lead us to probabilities over 1, and remember, that's not allowed. So formulas for compound events, there are 2 of them. Remember though, you can always rely on your intuition, what we did above. Listing out the 2 events and then only counting the unique events that show up. That's using your intuition. Sometimes we're only given probabilities with numbers and we have to apply the formulas. So here we go for the formulas. For mutually exclusive events, the probability of A or B is the probability of A plus the probability of B. They don't have anything in common, so we just get to add those 2 probabilities together. Not mutually exclusive events, probability of A or B is the probability of A plus the probability of B, but we're going to subtract out what they have in common, what their overlap is. Okay? To give you an example, I'm going to use G up here, rolling an even number or rolling a number greater than 3 as far as applying this formula. So probability of even or greater than 3, and this equals the probability of 2, 4, 6 or 4, 5, 6. So probability of 2, 4, 6 plus the probability of 4, 5, 6, but we're going to subtract out the probability of 4 and 6, the overlap. So if I put this in the formula, we've got the probability of A, because A is going to be even, B is greater than 3, probability of B, minus the probability of A and B. What do they have in common? A and B together, what do they have in common? And 2, 4, 6, 3 out of 6, 4, 5, 6 is 3 out of 6, but we know this probability cannot be certain because there are numbers left out. 1 and 3 are being left out of this group of numbers. So our answer cannot be 1. And that's why we subtract off 2/6. We have double counted the 4 and the 6. And so to correct the double counting, we subtract out one of them. Subtract out one of those instances of the repeats. And so 3/6 plus 3/6 minus 2/6 will give us 4/6, which is 2/3, and that's exactly the same answer we had before. And so that shows you how we can still apply the formula to the same type of problem that we did using intuition.